Okay, so in continuing with what we have regarding gravity, and I'm going to pause for just a moment. Okay, just mention a little something about unit conversions. And let's say that working with feet per second, okay, and let's say if you have a velocity of 90 miles per hour, and I put this in the context of feet per second, okay, so we have in the case of miles, okay, well, for every 1 mile, okay, there will be 5,280 feet. And in the case of what I have converting in terms of seconds, now for each hour, we have 3,600 seconds. Okay. And in terms of canceling out units, we can have 5,280 feet for each mile. So you have miles will cancel, and also we had the cancellation of hours. And if you were to multiply altogether, okay, and turns out that for 90 times 5280 divided by 3600, and we would have for that particular velocity have 132 feet per second. Now, and let's say that going back to the very same tower, and let's say that so you have a ball that is going to be thrown downward, unlike the projectile which was fired up, where you have the ball to be thrown down. So you have 90 miles per hour, or in this case, 132 feet per second. You have thrown downward from the same 1,000 foot tower. And we can have pose the questions. Okay. How long will it take for the ball to strike the ground? And once the ball strikes the ground, what would be the velocity? And so for what we have in this particular case, all right, so we're going to go back to very much the same equations, still working with the gravitational constant of 32 feet per second squared. And we have, in this particular case, okay, so just finishing up my questions. Okay, so we're going to have over here. So once again, just a bit of history to repeat itself. So you have, again, for the velocity, same scenario, you have negative 32t plus c1. Okay, now we have initially a ball is thrown downward at 90 miles per hour, but in the case of feet per second. Okay, so you have for the initial velocity, so we're going to have, we put this in the case of minus 132. So just looking at throwing the ball downward. So you got minus 132 is equal to negative 32 times 0 plus c1. And so we have c1 is equal to negative 132. So for what we have in the case of the velocity, okay, so you have negative 32t minus 132. And in the case of what we have regarding distance, and just separating the differentials regarding distance and time. So we're going to have, upon integrating, so we have y is equal to negative 16t squared minus 132t plus the second constant. Okay, and now, once again, initially, okay, the ball is thrown downward from the tower. And again, the tower is at 1,000 feet. And this will turn out to be the value of the second constant. Okay, notice that the first constant is not negligible, and neither will the second constant. So for what we have at any time t, so y of t, so this will be negative 16t squared minus 132t plus 1,000. Okay, and whenever the ball strikes the ground, okay, so for what we have in the case of y of t, okay, so you have y of t is equal to 0, and in turn, we have negative 16t squared minus 132t plus 1,000, and we have even number coefficients throughout. And to make this into a very user-friendly quadratic equation, so if I were to divide by negative 4, so I'd be looking at 4t squared plus 33t minus 250. Now there will be two values of t, but I'm interested in just the positive one. And in this particular case, now for the amount of time, okay, there will be about 4.792 seconds. So that's how long it's going to take for the ball to strike the ground. And in terms of what we have for the velocity, okay, so again, we have with the velocity at 4.792 seconds. So we have negative 32 times 4.792 minus 132. And for this particular outcome, okay, so we have about negative 285.34 feet per second. So for what we have contextually, so you have about 285.34 feet per second downward.